Hello?
Hi.
Okay, alright, Dankeschön, for all those others. Okay, so this is going to be our Saturday AP test review. A lot of stuff is going to be kind of quickly. You guys got highlighters to go over certain concepts and things that need to be just refreshed, because a lot of stuff we haven't actually covered in a while. I was hoping that you guys would all have already done like the Khan Academy review, at least the limits and definition of limits and the limits and continuity, because that was a lot of stuff that we covered. So we know that the basic thing of a limit is that all right, for a limit to actually be valid, what are the two things that have to happen? There we go. Both sides have to be going to the same number, right? So does a limit have to be continuous? No. No, a limit cannot, because I could go to a hole, right? Both left side and right side can go to a hole. So that's the basic continuity. It's a limit. But now, can I take a derivative or integration with a hole? Say no. No, because for a derivative and an integration, it has to be continuous over the interval in which that we're working with. So that's the reason why I wanted you guys to actually go over and at least the bare minimum in that one in Khan Academy, because those are a lot of things that did not apply to the derivatives and integrals that we've already done. All right, application of the derivatives. So a lot of things basic things going over. So from the packet right here, we're talking about finding the derivative at a point. So, okay. So finding derivative at a point. So we're going through, this is a different notation than I used. So, okay, pay close attention to that. So that's going to be like the dy dx. We know and understand that dy dx is stating that's the derivative of y in terms of x. And so this bar here, and then it's x equals 3. So that's just inputting 3 for my x value. And then my basic, try to turn my equation, my point slope. Okay, when I'm trying to find the equation. Dying. All right, trying to find my equation right here. All right, so one of the other ones that trying to get to, equation of the tangent line. So now, basic is we have to find the slope first by finding the derivative, then we plug in the point, find the derivative, plug in the point here, and that's just going to give me the slope. That is only going to be my m in my function of y equals mx plus b. That's only going to be the m for that function. That's all that is going to be. The 33 there, that's all that's going to be. And then we have to plug it back into the point slope. Now, let me see, where is the other one I was looking for? Example 4, bless you. Okay, example 4 is the one I wanted to actually look at, because this is not something that was a big deal, but it's one of those weird things that you got to try and remember what it is. So the normal, okay, normal. A normal is perpendicular to the tangent. So a normal is perpendicular to the tangent. So because of that, I know that if, right here it says, find the equation of the normal line to this at this. So I would go through and I first find my slope. So by doing that, I'm going to find y prime here. So I'm actually going to work it out on the side, because I hate reading through other people's work. I really do. All right, so it's going to be y prime is equal to, from here, okay, the exponent goes up front, and then I subtract 1 from the exponent, so it's going to be 5x to the 4th minus 4x to the 3rd, and this 1 drops off. So right there, and then we're going to find it at x equals 2. So y prime at 2 is going to be, this is going to be 2 to the 4th power is 16 times 5. 80? Yeah. 80. Hey, no worries. It's early. All right, then we have right here 2 to the third power is 8 times 4 is 32. So y prime of 2 is that 48? Yeah. So now this is the slope. This right here is my slope of my y at point x. Now what we need to do, so the slope is always rise over run. But since I have the number 48, my rise is 48, but my run is 1, right? So my rise is 48, my run is 1, but now I need to find perpendicular to that. So the normal is perpendicular. So don't forget, symbol for perpendicular is a little upside down T, and it's always going to be opposite reciprocal. So opposite reciprocal slope. So that means this is positive 48. This is positive 48. So if it's opposite of that, that's going to make it a negative 48, right? And I take the reciprocal, and so that this is 48 over 1. So reciprocal is going to flip that over. So it's going to be 1 over 48. So altogether, it's going to be negative 1 over 48 is perpendicular. That's the new slope. That's the new slope right there. So that's important. So this is the normal slope. So that's my normal slope right there. So now I could actually do the same thing that I did. So what I had, so now I have an x value. So in this thing, I need to also have a y value. So to get the y value, I need to plug this back into my function to figure out what my y value is when x is equal to 2, right? So if I plug that in, 2 to the 5th should be 32. 32 minus 16 plus 1. So that my y value is going to be, is that 17? Bless you. Is that 17? I hope so. Oh, good. Okay, so I have now my point of 2 comma 17, and my perpendicular slope is going to be negative 1 over 48. Plug it into my equation. I know it's actually right here already, but like I said, I like working it out myself. I hate looking at other people's stuff because I don't know, sometimes I can't follow what they're doing, and I need my brain to actually go step by step on this. Alright, so for right here, it's going to be y minus 17 is equal to negative 1 over 48, quantity x minus 2. Now, so one thing about AP, well, you guys recall, what was the one thing about AP that we got to try and remember, especially on the free response? Leave it the way it is. Don't simplify, okay? Don't simplify, because if you do that and make a mistake, your answer goes from right to wrong. It's no longer, like, even though if you have this right, if your next step is wrong, that means that you lose that point that you just had. So leave it there unless you actually have to. Like a multiple choice question, you might actually have to turn it into y equals, or whatever form. Make sense? Okay. So I would leave it right there. Just call it a day. All right. So that was the normal, because that was a weird one. I wanted you guys to actually talk about right here. The next one that we had was parallel. Okay, so yes. Right here it is. So it says where the tangent is parallel to the x-axis. You're also going to have some that are tangents are perpendicular to the x-axis or parallel to the y-axis. So now if I think about it, if it's parallel to the x-axis, my slope has to be 0, right? The slope has to be 0 for that one. So for that to be parallel, that means that I want to know all the places in which that my slope is going to be 0. And that's when it's going to be parallel. You're going to have a lot of these functions that are going to be like, you're going to see on a graph, and you're going to have a relation. Like you're going to have a 0, like a big circle. And you're going to have to find the points on that circle that are either going to be parallel to the x-axis or perpendicular to the x-axis. Now, if it's perpendicular to the x-axis, that makes it a vertical line, right? Yes.
Yeah.
So my vertical line, what is the slope of the vertical line?
0.
Not 0. Is it straight up and down? What's the rise on straight up and down? Goes up, right? And what's the run? 0. That's the important part. So it would be my rise, said rise, R-I-S-E, okay, would be, you know, basically I can go up to infinity, and my run would be 0. Now, the big thing about this is I cannot divide by 0, right? Can't divide by 0. This is undefined. So I'm going to have to find places in which I have a undefined slope. Undefined slope. So if I'm actually going to do something that is going to be an undefined slope, especially if I have a problem that is a fraction, okay, some type of quotient rule or something. So I'm going to make one up right now. So if I have something where it's going to be like 3x squared minus 5 over, let's say, x quantity x minus 2 squared. So in a function like this right here, to find out the places that this is going to be undefined, I would take this right here, I would set only the bottom equal to 0. Okay, this is also one of the AP test prep reviews that I did recently. You would only set the bottom equal to 0. So on the free response type of question, you would get your first point by stating, all right, if it's going to be undefined or if it's going to be a vertical line, that means that it's going to be undefined slope. So that means the bottom has to equal 0. So all I have to do to get my point off of this would be x quantity x minus 2 squared equals 0. So by setting only the denominator equal to 0, that means that I'm going to find a place where it's going to be undefined. Because every time that the denominator is equal to 0, it is undefined. So this one, in this case, I would go, all right, x equals 0 using 0 product rule. So there's that one's going to be equal to 0. And now set this other thing right here equal to 0. So I'm going to set this. So I'm going to say x minus 2 equals 0. But I don't have to do it twice because it's going to give me the same answer on that one. So when I set this equals 0, so x equals 2. So I'm going to have two places on this function right here where it would be a perpendicular to the x-axis or a undefined slope or a also vertical line. So I would have it when x equals 0 and when x is equal to 2. All right, let's see. Okay, so parallel to the x-axis. Okay, we talked about that. So that's going to be when my slope is equal to 0. Okay, so that would be the rise. So the rise in my rise over run would be equal to 0. Okay, so next thing, mean value theorem for derivatives. Okay, this is super important. Now, it's basically saying mean value theorem is the average value. Okay, mean value theorem for derivative where the curve must be continuous on the interval. Good morning. You're welcome to some pastries, and there is the packet there and highlighters. All right, so must be continuous on the interval and the endpoints. So it's got to have brackets. Okay, it has to be like this. Okay, so, and it's also got to be differentiable. So for it to be differentiable means that I need to be able to find the derivative. There is no holes. Okay, there is no holes. There is no, I don't know, pointy points, sharp turns. Okay, so for that one right there, so mean value theorem. Okay, so we have this function right here. Looking at this, oh, let me scoot it up some. There you go. So here's my function, and looking at this right here. So at the interval from 1 to 3. So that means that I'm going to plug this in. My values of my endpoints are going to be 3 minus 1 on the bottom. And now it's going to be my functions on the top. So my function, so it's going to be, this is f of 3 minus f of 1. So that's going to give me 9 minus 1 over 3 minus 1, which is 2, which is 8 over 2, which is 4. Okay, so now this is important right here. So now this is actually going to be the average value. Okay, MVT for derivatives could be written like that. There's such number C. So now f of C is this. That's important. So the f of C is equal to this because it's going to be asking you somewhere over here that you're going to find where is this going to be equal to 2. Because I have the slope. So that means that there's going to be some value in here of this where my slope is equal to 4. Somewhere in between. Okay, that's all it's saying it. And now, what I could do is, let me see. So notice, oh wait, different one. Okay, so says because the derivative of f prime of x is equal to 2x from my function, which was x squared, right? F prime of x is just 2x. Okay. And then plug in, okay, for right here, for x, so then figure this out. So now, from this function, I'm going to set it equal to 4. So I want to know where is my slope equal to 4. Okay, so it's going to go, and you're going to go 4 is equal to basically my 2x. And then I'm going to go divide by 2, so x is 2. So what this means is that on the closed interval from 1 to 3, my slope will be 4 when x is 2. Okay, I guarantee you're going to have, a couple of these problems on there. So you have to be able to find the slope, and you have to find out when. So this is going to be my c value for right here. For what c value? So that is a common AP question. So for what c value does the mean value theorem hold true? So it's going to be, when is it going to be equal to this right here? At what value do I have that? Okay, so that's basically, what it's trying to get at. Okay, so let's see, covered that one. So, all right, next one, Rolle's theorem. Okay, Rolle's theorem is a special case of this. Now, so for this one right here, so Rolle's theorem is special. That means that my endpoints are at the same location. The endpoints, so if it's going to be f of A is equal to f of B. f of a is equal to f of b, and it's also stating that right here, it's continuous on the interval, differentiable at everywhere on the interval, and right here. So from here, your slope, so if you just do the endpoints right here, they're going to be the same. Then if I'm doing that, that means that there's a function that's going to look like this thing right here. So it's either going to go up, go down. It could be a whole bunch of different wavy lines here. But at my endpoints, they're going to be the same. So that means that it has to go up to something and come down. Or it has to also, it could have gone down, then come back up to actually be here. But somewhere in between here and here, you're going to get that my function has to curve back down where I will again get a slope of 0. So I should have a slope of 0. So it's a mean value theorem. So it's the same thing that we did a bit ago, but in this case right here, that when I find my slope is equal to 0. So I also could find somewhere on here that my function will be equal to 0. So this, and it only applies if right here it's not just going to be a constant function. A constant function would be like, 2. The slope will always be the same thing. So it would always be 0 because my function is 2. It is a horizontal line, so it just is always going to be that. So we're going to find it somewhere in between there that it's also going to be the same thing. All right, does that make sense or no? Questions over that? So all it is you're going to find the slope. So Rolle's theorem and mean value theorem, slope formula, which is f of b minus f of a over b minus a. Rolle's theorem, this gives me 0. But mean value theorem, it gives me some other number. It will give me some other number. And for this to work, okay, here I'm going to have some value that my function is also equal to 0. And then I find out where that is, using the same methods that I did for mean value theorem. All right, let's take a look at nope, mins and maxes. Actually, before I get into that, so this is what I'm going to do. I'm going to take a pause to my video. You guys are going to try some of these right now, and a couple people have to check in with their overlord. Okay, like I said, come back for this. Okay, first, okay, right here. So for this one right here, let's start plugging it in to find out what the slope is going to be over the interval. So I'm going to go ahead and plug in. So it's going to be f of 1, which is going to be 3 plus 5 minus 2 minus negative 1. Okay, minus, let's see, negative 1 for all these. That's going to be 3 minus 5 and minus 2. All right, so that's going to give me 8 minus 2 is 6, and minus, that's going to be, what's that? That's negative 7, negative 4 over 2, which is 10 over 4, which I get 5. All right, did you get 5? Mm-hmm. Okay, good, because I'm hoping, because I heard a couple different things. All right, so we came up with 5, and so let's go ahead and try to figure out what it is. So my derivative, so my f prime of c, right? So I'm going to try and figure this out for c here in a minute. So I'm going to go this, which is going to be 6x plus 5, and then set that equal to 5 is equal to 6x minus 5. So I'm going to go plus 5, 10 equals 6x, and divide by 6, x equals 5 over 3?
Is this the first one still?
Yeah. X should be 5 over 3. So my x value, or my c value in this case,
Why
No,
is
it's plus 5.
plus
You
5?
see the in the first.
Oh wow, I didn't, yeah, I'm sorry. Bam. Oh man,
It's just 0.
big issue. So 0 equals x. Dang, okay. Thank you, all you YouTube fans. Okay, out there. So when x is 0, my slope is going to be 5. Okay? Okay? Alright, good. I'm glad you guys were able to fix me on that one. Okay, so we did a mean value theorem for derivative. Let's try a roll. Did you guys get to any rolls? Roll. Just roll with it. Roll. Let's try 8. Yeah, let's try 8. Alright, so if I'm going with 8, it's going to be, let's go ahead and plug this in. So f of 1 is going to give me 1 minus 1, right? Okay, so it's going to be 0. And then that's going to be minus 0 over 1 minus 0, which is 0. So there it is. So that's rolls, right? Okay. So that means that for this one right here, for the endpoints, if I were to plug this in, it'd be, let's see, 1 minus 1. All right, so now from 0 and yeah, right here. So find c values that satisfies that one right there. Okay, so now, what was the next part? So I got a slope of 0. And what else do we have? Something else actually had to happen here.
F of A and F of B have to equal 0.
There we go. F of A and F of B equals not 0, they're just got to be equal. So F of A has to equal to F of B. So we get those. So if we plug it in, so F of A is going to be 0, F of B is going to be 0. So here I get 0 equals 0. All right, so that works. So that means that for this function right here, there should be some point, okay, some point. This is going to be continuous on this interval. There is no, because this is a cube root. It's a cube root, so it's not, I'm not going to have any issues on this. Okay, so let's see. Now let's go ahead with this. So now I'm going to find the derivative. So f prime of x is equal to 2/3 x to the negative 1 over 3 minus 1/3 x to the negative 2 over 3. Yeah? Okay, good. All right, so now, since I have that, and I'm going to set it equal to 0. So set this one equal to 0. So let's see. I'm going to rewrite this. So now it's going to be 2 over 3x to the 1/3 minus 1 over 3x to the 2/3 right here. Common denominator is going to be what? 3x to the 2/3, right? So what is this one missing? 1/3, right? So it's missing a 1/3. So I multiply top and bottom by x to the 1/3 over x to the 1/3, right? So I'm doing that there with this. So that's going to be a common denominator thing. So that's going to be a common denominator thing. So I'm going to take care of that. So that's going to be 0 equals 2x to the 1/3 minus 1 over the now common denominator, which is going to be 3x to the 2/3. So there's my common denominator.
Wait, I got kind of like behind a little bit.
Yeah, what's up?
All you did was multiply by x to the 1/3.
Yeah, because this is 1/3 and this is 2/3. They both have the 3, right? So they both have a 3, but this, if I multiply this, 1/3 plus 1/3 is going to give me 2/3.
Yeah.
So I add my exponent. So this was missing a
Okay.
1/3 more.
Alright, just making sure.
Okay? So right here we have this. Okay? So we have everything we have there now, right? So now, since it is a common denominator, I can get rid of my entire denominator, thanks to this 0, by multiplying both sides by 3x to the 2/3. Okay? Because 0 times 3x to the 2/3 should give me 0. So that's going to wipe out that little nasty. So now it's going to be, let's see, 0 equals 2x to the 1/3 minus 1. Add 1 to both sides. And then, so it's going to be 1 equals 2x to 1/3. Divide by 2. So I'm going to come over here. So I'm going to bring that up. So now it's going to be 1/2 equals x to the 1/3.
Don't just say square root? Or not the square root, the cube root?
Not roots. Isn't this already a root?
Yes.
I need a power. Right?
Yeah.
Okay, so how would I take care of that?
To the third?
So I need this to be x to the first, right?
Yeah.
So I need to multiply, okay, so I need to raise this both sides to a power. So what do I need? Third, right? So I'm going to raise it to the third power. So if I do third power, because power to power, I multiply, right? And so this is actually just 3 over 1. So this is going to give me just 1 right here. So I get x equals, now I do the same thing to this side, third power there. So when I do that, that's going to give me 1 to the third power over 2 to the third power, which is 1 over 8. So my x value is going to be 1 over 8 when my slope is going to be 0 on the interval from from 0 to 1. So that is the point in which that satisfies that it's going to go up or down, and I can figure out concavity later on, but I'm going to figure it out. I can. So left side and right side are both, my functions are equal. My slope is equal to 0. So that's that satisfies that I'm going to use Rolle's theorem. And then I did all my work that I actually did. So derivative equal to the 0. So there is some point in between here and here that the slope is also equal to 0. So in this case right here, let's say if it goes up, then it's going to come back down. It's going to go up and then come back down. So at the point in which it changes direction, it is going to be at x equals 1/8. Make sense? Questions before I move on to the next thing? All right. Hey, my dudes, is everything okay?
Yeah, we just have to like.
Oh, here, I will stop recording for the sake of. All right, sorry.
For the sake of teaching.
Yes. For the okay.
Are we going to a meeting?
Something like that. I don't know. Listen, I'll stay as long as you guys want. I actually have my math class coming in here. My master's course. We're going to come and actually do some math in here. All right. Yeah.
What? I said when. He doesn't know.
Oh, right after this.
Oh.
Yeah, so I don't know. Like, I keep looking at my watch because they keep texting me. Like, I'm like a group chat, and so every time, like, this stupid thing is blowing up, I have like 40. Okay, so, and yeah, we might keep Piotr over here because he could actually tutor us on how to do this stuff. You know, this master's level math. All right. Okay, so applied maxima and minima. Okay, so right here it says maximum, minimum values, function where the derivative of a function is 0 or where the derivative fails to exist. This last part right here is part that a lot of people forget about. Okay, so where it fails to exist. So now, relative means it's going to be over some point or some interval in which that, you know what, if it like this, so for a relative, I would have a curve here, but if you notice, it's not actually the maximum of the function, especially when you have functions that go up to infinity or down to negative infinity. So because of that, these are going to be relative to whatever my interval is. So reading through here, it says at a point where the first derivative equals 0, the curve has a horizontal tangent line at which at the point it could be reaching either a peak, a maximum, valley, a minimum. There's a few exceptions to every rule, and this rule is no different. Okay, so right here, does that make sense? So that means that at this point right here, it is slope of 0. Right here, also slope of 0. Okay. Now, in a function like this, so absolute maximum and absolute minimum occurs either at an artificial point or an end point. In the figure below, the two indicated points are absolute mins maxes. A relative minimax could also be an absolute minimum. Maximum. Dang it. All right. Okay. Glasses, please. All right. All right. So right here, absolute. If you notice, the function is curving down on both ends. So of my function, that is the highest point it's going to go. So that's going to be absolute. Now, if you notice, this function has endpoints here, right? Now, one thing that it did not say, has to be brackets. Has to be brackets from A to B. Has to be brackets because that means I have to include that. Have to include that. So right here, if this was an open dot right there, I could not include that because yes, it is going to something that is approaching that number but is not equal to that number. So it is an open dot at that number. So I could not actually say what that number would be because it's getting super close to it. Okay, yeah, it's not going to be that number. So it's all numbers up to it except for that number.
So it's kind of like an asymptote.
Yeah, kind of like that. So in the sense of real numbers, it would be like if this was 1.0000000, yeah, on like a infinite number of zeros with a 1 right next to it. So it's getting super close, but since it's not equal to that number, I can't really say that it's going to be there. Okay, because that's not a number, it's more of an idea. So it's going to come close to that, but it's not. So it has to be, if I'm doing my endpoints, it has to be these. Okay? So, critical values, function. Okay, if a function has a critical value at x equals c, then the value of the relative maximum, f double prime, ooh, second derivative test right there. Double prime is less than 0. Okay, maximum. Okay, and minimum right here. So now the hand test. Okay, so with this, so you take your thing right here. So if it's opening up, this is positive, right?
Yeah.
This is positive, it's opening up. So that means that my finger right here, right there. Can you guys see that? All right, gang related here. All right, my finger right here, this is a saddle. So this point right here is going to be my minimum because this thing is opening up. It is a positive second derivative, so that means it has a minimum. Same thing goes the other way. All right, there we go. All right, so it is opening down, so this is a negative. So just think of this as a parabola right here, right? It's a negative parabola, right? So it's opening down, so that's negative. So that means because of that, my second derivative is negative, but this is going to be a maximum. Okay, that should be, throwing up those gang signs there.
Calculus game out here.
Yes, calculus gang. All right, so let's see. Where was the problem I was going to do? Okay, so right here. It's right here, number 3. Let's see if I can actually get that right out. Okay, there we go. Bless you, I think. All right. A rocket is fired into the air and its height in meters at any given time t can be calculated using the formula. So now, h of t, that's the height. Now, this is super important to understand this. This is position. This is my position function. So, this would be like the s of t. This is the location it is going to be when t is something. That's super important to understand because otherwise, if you see something that says feet per minute or second, something like that, that means that's going to be a velocity. That's going to be my first derivative there. That means that it's something different. So this is position. So in my hierarchy, it's down right here. So it's going to be s of t, which is my position. Then it goes v of t, that's my derivative, which is also the s prime of t, is my velocity. Is it C-I? Yeah, C-I-T-Y, right? Velocity, something like that. Okay, and then take the derivative again, which is going to be my acceleration. So a of t is equal to v prime of t, which is equal to s double prime of t. And that is my acceleration. So there's a hierarchy of that. So it's while you're reading through the question, that's important to actually do. Okay, make sure you know what you're doing. Okay, so calculated using the formula here. Find the maximum height of the rocket at the time that this is going to occur. So now let's talk about domain of this. My domain, so my real life type of domain. What t's am I going to be allowed to use? Positive, very good. Can I use 0?
That's a starting point. But you can-
Starting point, yes. Yes, you can. Okay, because you need to know what it is going to be at your starting position also. Because starting position right here, this means that it's actually starting something. So it's actually starting at a height. So if I put in 0 for this, my starting height is 1600. Right? So that's going to be my starting position. So I can start with 0. Okay, so it's going to be positive numbers. I'm going to have 0 and then going to some number in which that this is going to go back down. So this is actually going to be when this is going to be equal to 0 also. So I can't have, when I plug in huge t's, I can't end up with negative numbers. You can't make a crater with that rocket. Okay? So you're not going to do that, right? So that's important to understand while we're doing this. So find the maximum height. So that means that I need to know when is this going to be all the way up at the top, right? So this is just a basic rocket, so it means it's going to start here, okay, in my thing. So it's actually starting off the ground, going and then hitting down right here. So it's going to be some height right there. So that means I'm going to set my derivative equal to 0 because that's going to be the maximum. Okay, so let's do that. So it's going to be h prime of t. So h prime of t. So this is my height. So this is going to give me 196. And that's minus, that's going to be 9.8 t. Now, since that is my derivative, I set that equal to 0, so I get 0 equals 196. Oh man, come on, dyslexia. 196 minus 9.8 t. So it's going to give me some value, so it's going to be 196 divided by 1 point. What do I get what? Okay, right here.
Oh.
What's the derivative? So it's going to be 2 times this. Okay, no worries. So 9.8, and for the sake of argument, I'm going to do this one for you. So it's going to be, let me see, 196. So negative 196 divided by negative 9.8. So it gives me 20. So t equals 20. So t is 20. So now that is super important. So now, in the real life sense, you guys actually have to understand and actually tell me what that means. Tell me what that means. So conceptualize this. What does that actually mean?
It's the maximum height, the maximum time in which it reaches the height.
Yeah, it takes 20 seconds, right? At 20 seconds, it is at its maximum height. That's very good, right? It is at its maximum height at 20 seconds. But let's go back to the question. Find the maximum height. So I know when is the maximum height. What do you think I should do to find the maximum height? Plug it in. Very good. I'm going to plug in 20 into my function, which is a function of my height. Okay, that's super important right there. So plug it in there. So calculate y is 1600 plus 196 times 20 minus 4.9 times 20 squared. So it's going to be 3560. And what are my units right here? Look. Meters. Right here. Height in meters. Meters. Okay. I know this is just a lot of algebra type stuff, but understanding and doing these is actually super key. This is actually very key to what we're doing for all of this. So, okay. Now, one of my favorite problems right here. Example 4. Okay.
Are we gonna be able to take these home?
Yeah. I made copies for you. So yeah, these are yours. You can take the highlighter with you too. So I'm still looking to see if we could use a highlighter on the AP test. I know on some tests you can, but I don't know about that one. Some people like. Ugh. Okay, so now we're back to this. Okay, so now listen up, you guys, right here, please. This is super important. So on this one right here, these are the problems that usually mess up everyone. Everyone. So whenever we're doing this, you're gonna have. So it says right here, hardest part of these word problems when you have to set up the equation yourself. Okay, now, this is going to be on every single AP exam. And I guarantee you, most of the time, you're not going to be given a shape. You're not. So I'm going to do this right here. And, okay, so if you guys could, up here, I'm going to show you guys how to do this and actually set it up yourself. Because, yes, there is a picture already there, but I hate using other people's stuff, like I said. All right, I can smudge in my glasses. It's killing me. All right. It says, Max wants to make a box with no lid. Super important. No lid from a rectangular sheet of cardboard that is 18 inches by 24 inches. So now, we start with making a rectangle. So 18 by 24. So 18 by... I said it, didn't I?
Plus 4. Yeah.
I said it.
You should have just done 20 plus 4.
Oh, man. Anyway.
You need more coffee? Yeah. I'm gonna go get you some.
They frown on teachers using, math. Anyway. All right. So, I started there. So to do this, to actually make something out of this, the box is to be cut, okay, is to be made by cutting squares, square of side X size from each corner of the sheet. So that means if I'm going to cut out something there, cut out something there, there, and there. So in this case, I am folding this up, like this. So I'm going to fold this thing up, and so now what I just did with my dotted line right there is this. Actually, you know what? I like colors. You know what? Bam, all this. All this. This is going to be the base.
Those coloring skills.
I know, right? I know.
Wow,
I
third
don't
grade
like
level.
Woo! I know, right? Hooked on phonics work for me. I mean, yeah.
Gotta go college history.
Hey, can you fill out one of my papers for him? Or did you fill one out for him? Yeah. Okay. All right, so that's going to be the bottom of the box. Okay, that's going to be the bottom. So that means that when I fold this thing up, so it's going to go this height. So I'm going to cut this out, and I'm going to fold this piece up here. So I am like super jazzed about this. Watch.
Wait, what?
Wow. Oh
You're
man.
wasting my time.
Huh?
You're wasting my time.
I'm wasting your time. No, because I'm doing it right now.
I can imagine how to fold a box.
Listen.
Not everyone can.
I know, right? Not everyone is super geniuses, remember? Oh, man. Listen. Okay. Now, yes. I'll tell you that 90% of Americans don't even know Moldova is a country.
I know. More than that.
I didn't know that was like a thing.
I thought it was a state.
Show us the. I thought it was like a. Okay.
So, yes. So, everyone already assumes that you're from Russia anyway. So, we just consider you Russian.
Are you trying to flip?
You should probably edit this out of the video.
Why? Like, not like I'm gonna have people from Moldova actually like talking crap about my math. Okay, so what I did is, okay, for the sake of,
Yeah, you have to cut it.
I actually have to cut it.
If you don't cut it, it won't be able to pull out.
Yeah. Okay, so here is my square. Here's my square. Oh, wait, you know what? White background does not help. Okay, so here's my square that I cut out, and this is gonna be x length by x length, right? A square is important. It is a x by x. How do you find the area of a square?
X squared.
Length times width, right? So it's x squared. Very good.
I thought it was the middle times.
Stop making fun of his face. He was like, it's not a
That's
square.
that was the area.
The area.
The answer equals the area.
It's okay, Roger, you're doing good.
What's the area?
I'm crying. I'm not just crying on the inside. It's on the outside now. Okay, so now, here is what I just did. Okay, so by cutting out my two pieces here, I'm folding it up right there.
Wow.
Okay.
Wow. Arts and crafts.
Wait, what if we don't have scissors during math test?
Yeah.
How am I supposed to pen my test?
We
How am I
seriously won't
supposed to
have spare
visualize
people.
it, man? He was like, man, I should have left you at bed. Oh.
So,
All right.
Thanks for the visual.
optimize.
You're welcome. You're welcome. Okay. And you're welcome for all the pastries. Hope you don't choke on them. All right.
I already did.
Can I have more pastries?
Yes.
I know it came in late.
Yeah, go ahead.
I was
She's
teaching
not
kids
taking them
geometry.
home.
Oh, yes, yes. You need a lot of brain food for that. So now, I want you guys to pay close attention. So now, what I did is I cut off this value of x, right? And I also cut off this value of x. Same thing goes for here, x and x. So since I'm cutting off some value from here, I know the length of this now is going to be whatever it was, which would be 18.
2x.
18, yes. And I cut it off so it's minus 2x. Yes? Okay, and my other side over here is going to be the same thing. Since I started with 24, I start with 24, and I'm cutting off 2x again.
Whoa.
All right.
No.
And then the height
Okay.
is x.
Take the
And so the height of the volume of, don't laugh, okay, going up here is going to be the x that I cut off from here to here. So that's important. That's the reason why I made this, so you guys could see the height of that now. So we need to ask, so I now have this, and I'm trying to maximize the volume. So I'm maximizing the volume. So now, in this whole thing right here, I know that I'm gonna have that the volume would be length times width times height. So let's set that up. So volume is equal to the length, which is my 24 minus 2x, times the width, which is going to be my 18 minus 2x, times the height, and as this thing goes up, it's going to be my x value, because that's the piece I cut off from both sides and I folded it up. So now, given this right here, I now have an equation for the volume. Now, if I'm maximizing the volume, okay, so the maximum volume, right? So that means I need to set that the volume equal to the derivative, right? Equal to 0. So I could do this a couple ways. So I could go, I can go through and do product rule a couple times here. Nah. Or let's do my distribution. Okay, I like distribution. It's actually going to go a lot quicker here. So when we do this. Okay, so now if I do my distribution, so that's going to be 24 times 18.
432.
One what?
432.
432, thank you. I know, right?
First time.
All right, so we get 48 x minus 36 x plus 4x squared, right? And I still have to distribute out my x that I have right there. So together, let's go through combined like terms and give the x's. I'm going to have 4x cubed, and that's going to give me together, that is 84. Yeah, minus 84 x squared and plus 432x. That's the equation for my volume, right? I haven't done anything to my volume yet, right? All I did is I have the equation now to figure out the volume of this shape. So all I have to do is figure out what x's I'm going to have. So that means I take the derivative of this nasty. So let's go ahead and derivative this thing. So that would be a v prime. V prime is equal to 12x squared minus, was it 168x and plus 432. And so that's my v prime. Set it equal to 0. Please tell me that there's a factor of 12 here.
No.
Oh, crap.
Four. Yeah, it's 4. Yes. No?
There's a factor of what? 4? Okay, so 4, and then I get 3x squared.
Wait.
Factor of 12.
Yeah,
You
it's
can do
12.
12.
There is 12?
168 divided by
Hello?
14 is 12. 432 divided by
Okay,
12
yeah, okay.
Nice.
Okay, thank you. All right,
We blame the
0 equals, I know. Okay, Moldova, they don't have calculators. So
There you
yeah.
go. Those kids.
Yeah, that's why we don't have a Moldovan NASA. All right.
That's true.
All right, so we're factoring out of 12.
We don't really have an American.
X squared.
That's the X, so.
All right, so x squared. So what is 168 divided by 12? So it's minus 14x and plus
Let's see. What is
It's
it?
too big of a number.
Yeah, 36.
36. There we go.
You guys do the ones you
Okay, good job. All right, so now, because I factored that out, it's going to make my math a whole lot easier. So I'm going to take out the 12. I'm going to take out the 12, and now I'm going to go this, and I'm going to try to factor it. So I need to know when this is going to be equal to 0. So I'm going to go, that 12 goes away. So now let's see, factors of 36 that give me 14. Let me see, 12 and 3? Nope. 6, no. 9, 4, no.
You're gonna have to do
I know, I'm trying to avoid it. I'm trying to avoid it here.
Yeah, you are.
Yeah,
I know.
or use the calculator. What if you use the calculator?
I know. All right, so I'm trying to do it without the calculator because you're going to have this without a calculator problem. Okay, even though they are big numbers, we're no calculator on a lot of this. Okay, so
Minus square.
okay, b. Oh, dang it. Negative b
Negative b plus or minus the square root
plus or minus square root of
b square root.
minus 4 times
AC.
1 times 36. Oh,
All over 2a.
over 2 times 1.
Two.
It's still gonna suck.
Yeah, keep it.
All right, so it's actually not gonna be that bad because I know that's weird. So 14 squared is going to be 196. 196 and 36 times 4. 12, 14, 4, 144, minus 144, and plus or minus 14 over 2. And so that should give me 52. All right, so 14,
2 times the square root
52? Was 52 it?
Yeah.
52 over 2. Ah, crap, I gotta use a calculator anyway.
You can do 2 times the square root of 13, so it can be 7 plus or minus the square root of 13.
I know, but either way, you're still gonna have to figure out a value. So on this one, avoiding calculator, but we need calculator. Yeah, okay, yeah, we need calculator anyway. All right, you guys got the calculator? If you don't have it, grab it, please. Dang it, I was trying so hard to avoid the calculator. All right, so plus or minus, so it means it's going to be control, divide, 14, let's start with the plus, square root, 52, over 2, so I get a value of x equals 10.606. Now, don't forget, AP, you have to have 3 decimals, right? 3 decimals. AP is always 3 decimals. And then change that to a minus sign. And I have x is going to be 3.394. Now, on this problem, I get 2 values. Why is that not a good thing?
One value.
You need 1 value because it's 1 box, right? It's 1 box, and I have 1 x value. So that means that this is just my derivative equal to 0, right? So it's possible that I have mins and maxes here, don't I? Okay, so what can I do with my next part?
Throw your x's into your volume.
Yeah, I could do that.
You can check to see if the range of like.
Okay, so if I look at the range, okay, that's good. So, okay, so if we say x is 10.6, look at my values here. Can I have 10.6 and 10.6 on this side? No. So that means that my range cancels out my 10.6 value, right? Because I can't cut off 10.6 and 10.6 if I only have 18 there. Does that make sense? So that means that one's not going to work out. So because of that, my practical domain of this is that it cannot be, so for this right here, it cannot be more than what? What would be my practical domain for this? Yeah, it'd be 9, right? So x has to be less than 9. It can't equal 9, right? So because of this, x has to be less than 9. And this one right here, my x would have to be less than. So in all practicality, I've gotten rid of, okay, one of those possible answers, right? Because we just made the function, right? We made the function. The math is what it is. We made some function out of it, and we just have to understand what we're talking about. It's kind of like number of people on a plane. Are you going to have anything but integers? Can you have half a person? No. Is that right? A person's a person no matter how small.
I mean, what if they don't have body weight?
A person's a person.
What
They
if
still
you're-
have
So-
a brain.
I know,
what if
right?
You're in America during the 1800s.
Okay, listen. Either way,
I got 3/5.
Some
didn't
people
we
are
have
more
this
equal.
conversation yesterday, right?
It was your academy day.
Some
Okay,
people
all
are
right.
more equal than others, Mr. Contra.
Okay, 3/5, right? Okay, now, people on a plane, you're not gonna your domain of numbers, you're not gonna have less than 0, right? It's gonna be integers. So same thing as domains of stuff like this. You're not gonna have ridiculous numbers that are not going to work in my thing. My function says mathematically I can, but in the practical domain of what I'm working with is I cannot have less than that. So what else could I have done instead of check this? You said plug it in, right? So plug it in, that would work, okay, because I'm trying to figure out which one's going to be the maximum value. Okay, now, in that case, I would actually end up with a negative here. So that, you know, I would actually look and see, that would eliminate one of my answers, right? What else could I have done? Okay, what about concavity? Concavity would work too, second derivative. So if I take the second derivative, that would tell me if I would have a min or a max, right? So a min and max. So I could take the second derivative of this and figure out the concavity of that. And that would actually do the same thing. So we actually have a whole bunch of different ways, if you know the concept and you understand what we're talking about, how these will work. Okay? Are we okay? Like I said, these are some of my favorite problems because you have to be creative, and your number one thing to solve for this is be visual. Okay, draw something for this. You will have paper for this. Okay, draw all over it. Okay, you guys seen what the AP test looks like. Draw in there, write it. If you need some more paper, ask the evaluator, your proctor. You know, if you could actually have some scratch paper for this, because you know what? Look, I did all this right here for that one problem. You don't have that much room in your test booklet. So if you need more paper, that's fine, okay? You know what? Work through everything. All right, so let's take a look. Where was the other one? We have. There was another one I wanted. Where did it go? No. I think the related rates are on the next one. All right. So yes. Okay. So yes, you guys can keep these packets. So if you guys want to actually go over some of these other ones, you can. All right. So we're gonna go ahead and take a short little bit. I want you guys going over. We're doing some tutoring over this with each other, right? Okay. And so I'm gonna pause it. Can you get the light, please? All right. So number 3 was requested. I'm gonna go ahead and take a look at that one right there. Number 3. I've got to find my problem now. Solution 1, 2, 3. Okay, so it says what was the area? So my area was 384.
Yeah.
So my area. So I'm gonna go ahead. I'm gonna have a. It is a. Was it square? I think it said square, right? Said square. right here, and it has a fence going through it. So I'm going to have a y here, a y here, a y here. I'm going to have an x here and an x here. Okay, so I have values right here and here. So I'm trying to maximize my perimeter, right? So yes.
Yeah.
Okay, so if I'm maximizing the perimeter, I know that I need to have my derivative of my perimeter, right? So first, let's take a look. Let's set up an equation for my perimeter. So my perimeter is going to be equal to, I have my y's, which is 3y, plus 2x. And now, since I have another function that has to go into here, I know that for this to find the area, my area formula would be x times y, right? So that I have the x and I have the y. So I'm going to do this. So I'm going to say that 384 is equal to x times y. So what I'm going to do is, since I can't really do this with two different values, I'm going to substitute for one of my values. So let's say, for instance, I'm going to say that let's just say x. Okay, just to start off with something. So I'm going to say that it's going to be x equals. So I'm going to isolate this, divide by y. So I'm going to say that x is equal to 384 over y. So I'm going to replace this. So I'm going to replace my x. So now it's going to be p is equal to 3y plus 2 times 384 over y. Now that I have that, so go ahead, do a little bit of math, and what I'm going to do is, from right here, so I'm going to move this up, so I'm going to have a negative exponent here. So it's going to be p is equal to this times this, which is going to give me 3y plus what? 7 something. 768 y to the negative 1, right? Say yes. Okay, good. So now that I have that set up. So now I have gone through and I had a problem with x's and y's together, and now I only have one variable. So now with that one variable, I could go ahead and do my derivative. So p prime is going to be equal to, now everything is going to be in terms of y now, so it's going to be 3 plus, right? But when I take the derivative of this, the negative 1 goes out front, so that's minus, and it's going to be 768 y to the negative 2. Yes? Okay, so now that I have that, I have it set up. So let's go ahead and set this equal to 0. So now I'm going to have 0 is equal to 3 minus 768. Put my y's down, y squared. Common denominator is going to be a y squared, so I multiply this by y squared over y squared. So over here on the 3, so I'm going to have 0 equals 3y squared minus 768 all over y squared. Now, did I lose anyone on this? Is there any questions right here for what I've done up until this point? Don't be afraid to ask.
No,
If you,
I was just gonna say, like, why don't you just move 3 over on the other side and then multiply it by y squared? I don't know, to me it looks cleaner.
if you move 3 over here, then you would multiply by, it's the same thing, but the problem is when you set it equal to 0, this is a step that if you really want like all the points, because I'm solving this as if I would solve a free response. So when I solve the free response, I have to show like, be very distinct and very, 0 equals. So the derivative equal to 0. So whatever my derivative equal to 0 here. So that gives me my 1 point for setting it equal to 0 on this type of problem.
So if we did it.
So if you would have just went here and you said negative 3 equals this,
Would that be a?
no, because you would have to state that 0 is equal to my derivative. I know it's so picky, but listen, by showing your work, you're showing the process of everything. So the idea, the concept is that my derivative is equal to 0. That's all the concept. So that's the big idea. The derivative equal to 0. Just show that. Okay? Is that a hand over there?
No, yeah, but.
Okay. All right, so now that I got this, did I answer everyone? Okay, so multiply both sides by y squared, so the y squared is going to clear out. So I'm going to have 0 equals 3y squared minus 768. So it's positive 768 is equal to 3y squared divided by 3. So y squared is equal to, what's that going to be? Hold on. 2, carry the 1, that is 4, and that is going to be, let me see, oh crap, 4, 12, 2, 2, 8, 7. There we go. 247? Or no? I have no clue. Like, seriously, I can't math right now.
256.
250, ah, dang it, you're right. 256 is equal to, wow, y squared. I know, I just died a little bit on the inside. Not just on the inside, it's now on the outside. Okay. I just died in your arms tonight. All right, so it must have been something you said. All right. So it is this. All right, so now I'm going to take this and I'm going to square root both sides, right? So y is equal to plus or minus square root of 256. Okay, got the plus or minus, but now with the plus, will the minus even matter? No, because I'm not going to have a negative distance for my fencing, right?
Unless you're in Poland. But it's
Ouch.
Lord.
Okay, so for this one right here, it's going to be y value is going to be 16. So my y value is now going to be 16. So I can go through and I can actually plug it back in somewhere else. So I can plug this in. So let's go way back up to the top. Right here. So up here, I could actually figure it out for my x. Because now my x is going to be equal to 384 divided by 16, which should give me x is 24. So I have my y's, which is going to be here, here, here. My x's, which are here and here. So the length of this, so the area is going to be at 24 by 16. 24 by 16, so that's going to give me the area. But now, what if it asks for the total fencing? What would I do to get the fencing now?
plug it into the primitive.
Okay, so I'm going to plug it into this function right here. Now, so for that, so I plug it in, so it'd be here, here, right? So it'd be 3 times 16 plus 2 times 24, and that's going to be right here all my fencing together. Now, on this one, it only asks for the length and width here. Okay, we are maximizing the fencing, but it only asks for this one and this one. Okay, you got to be careful of how the question is being asked.
Oh, I think what got me confused is that it asked for the outer rectangle, so that's why I didn't add or include the midline.
Yeah. So when they do fences and they have something going through the middle, you always have to include those pieces, especially with all the fencing, because it's going to give you total fencing. It's kind of like if you have, they always have this one with the river. You have a cow pasture, fencing, and it would be a Y, and an X, right? So to maximize, to get my perimeter, right, the maximum or minimum, right, that we have, it would be a 2Y. We wouldn't include this one, right? Because that would be not needed. So we would add as needed and take away as needed to my drawing so I could actually have a diagram. You have questions?
No, I just find the idea of cows walking
They do.
Yeah, that's normal.
Yeah, it is normal. Yes, it is normal.
Yeah, I know. If it's a really fast rate, it carries the count really fast.
Yeah.
Like a motorcycle. It doesn't matter what I think, I just find it funny.
You're right, it doesn't. All right, so let's take a look over here. So now, some of my next favorite type of problems. Da-da!
Oh. I actually do like these.
Okay, related rates. So in your packet, 228. So if you guys fast forward a little bit, 228.
For my edited speech, so should I just speak in my Asian accent?
Let's see, Nicole. Huge favor. Can you give me some scratch paper from the up there? It's on the microwave right there. Yes. All right. So I'm gonna do this problem right here, but for this, like I said, I hate looking at other people's work. I like going over it and walking through it myself because I don't like other people telling me how to think through this, because each person is different, and if you think about it, not everyone actually thinks in the same way. Even though that you come up with the same end conclusion, you might actually, like, I am always visual. I am so visual on everything. I have to have a diagram, even for basic things. All my diagrams, if it is something that I could do, let's say we have some valedictorian tossing paper wads at the trash can and he can't do it because he keeps missing. So, that is a diagram in my brain of him trying to actually throw this. So I'm thinking about the velocity, I'm thinking about the distance, I'm thinking about the initial starting point where he's shooting it from head height, so that's about 5 feet up. Okay, so that means my t of when t equals 0, right? When t equals 0, so s of t equals 0, it should be starting at about 5 feet up. Okay, unless he's like one of those weirdos that actually like have both hands over his head as he's shooting the free throw there. Okay. Huh?
Those weirdos with their greater averages than everyone else.
Okay, so, but that's my point. That's my point. As you're doing this, you have, like, conceptually, if you visualize something and then you put it down, so you can manipulate or look around to see if there's something else that you could do with it. So it's not always going to be, all right, numbers. If you get a visual, so in your mind, so I'll guarantee you, so this is people that actually study memory and how to memorize and how to actually think creatively. And if you put formulas, so let's say you have a formula, okay? Something, it's just a bunch of random letters in your head, okay? And you just spit it out. Just regurgitate those numbers or letters whenever you need it, okay? What you should do is actually give it a picture. Give it a picture, give it a diagram, and then give it a location. So when I think about things in a certain place. I see a picture in a certain place. So if you guys are thinking about a diagram, so you're actually looking at, a sphere, a volume of a sphere, you look at, let's say, my whiteboard here, or I have a diagram and I have the formula right there. So if you guys could think of it as a picture, instead of just thinking of it as random, that's actually putting it in two different places in your brain. So your verbal memory of hearing it, visual memory, and then just the abstract of just those formulas coming out. So it puts it in different places so it concretes it a little bit better. So anyway, but yeah, I have to draw this. That's my big point. All right, a circular pond of water is expanding at a rate of this. So now it's a rate, isn't it? Say yes.
Yes.
So if it's a rate, I know that is going to be a derivative. Okay, that is a derivative. That is going to be important to understand later. So I have my circle pond. Yep, circular. Doesn't say it's exactly, but circular pond, okay, is expanding at a rate of this. So that means that my units are going to be this per second, right? So let's see. And so my first is going to be a formula of a circle. So my area is equal to pi r squared. My rate, which is going to be here, so right here, water's expanding, so this is going to be the area. Right here, it's going to be inches squared per second. So that means that it's going to go for this right here. So I know that my dA, okay, dt is going to be 16 pi inches squared per second. So you can look at the units help you out. It says this is square, right? Say yes. If it's inches squared, that's an area, isn't it? So therefore, if it's an area divided by time, that would be dA dt. Now, we know that since these are related rates, I'm also going to have a dr. So I'm going to have a dr dt. Okay, at what rate is the radius expanding when the radius is 4 inches? So that means that my radius is 4 inches. So now I have a dr dt, which I'm going to solve for, and I now know I have an r, which is going to be 4. So I know I'm solving for this. This is the one I'm going to be looking for. So I'm going to go through and I'm going to take this bad boy right here, and I'm going to take the derivative of this. And so, but when I'm doing related rates, if it's a variable, every time I take that variable, I know it's going to be like a dA dt. It's some rate related to time. So I know that I'm going to bring it down over here. Area is equal to pi r squared. So the derivative of area, because this is the only variable, it's just area 1a, right? 1a. So that's just going to turn into, so if I take the derivative of this a, it goes down to 1, doesn't it? Mm-hmm. Yes? So it's 1, so that would be 1 dA dt is equal to pi, right? Times, because pi is a constant, I'm leaving it alone. And the derivative of r right here is going to be 2r. And then since I took the derivative of r, I'm going to have to add a dr dt. 2r dr dt. Now, we are going through and it said we're trying to solve for dr dt. Do I have everything else that I need in this problem? Okay, I know what dA dt is, it's right here. I know what r is, which is right here. So dA dt is going to be one of my variables here, basically. So this is going to be 16 pi is equal to pi times 2. I know what the r is, so I could replace the r times 4. And that's all going to be times dr dt. So in this case right here, I'm trying to isolate dr dt. So since all this is a multiplication, to get it by itself, I'm just going to divide both sides by 8 pi, right? Yes. 8 pi. So I'm going to divide by 8 pi. So if I divide both sides by 8 pi, that leaves me over here on the right-hand side that I have dr dt is equal to 2. But now, this is a rate. So it's not just going to be a number, right? It's not just some number. It's not going to be just linear type of thing either. So it is going to be a rate in terms of some time. So you guys have to label it accordingly. So I know that my radius is going to be in what units? Say inches. Inches, okay, because that's what I had up here. And my time is in terms of seconds, right? So this means that it's going to be, it's changing at a rate of 2 inches per second. All right, are we liking this? I like it. I do.
I like it a lot.
I like it a lot. All right, everyone's favorite. Okay, ladder problem. Ladder, it's number 2. It's the next page. There we go. All right. All right. So it says a 25-foot ladder leaning against the wall and sliding towards the floor. Okay? Draw a diagram. Draw a diagram. So I'm going to take my wall. It's a brick wall right here. So, look, there's a little door. Okay.
Probably a character pronoun.
Okay. So anyway, so this is a pretty long ladder. So it is a ladder here. Oh crap. Here's my ladder. And all right. Now, depends on who built the house. Is this wall straight up and down? If I build it, it's usually not, but still, most walls are straight up and down. So if you put a wall, put it against a fence, right, or put a ladder against a wall, this is a right angle. Yes, say yes.
Yes.
And I like right triangles. Why do I like them? They have a hypotenuse, right? So my hypotenuse, yes. So yes, hypotenuse. All right. So this is going to be 25, right? Say yes.
Yeah.
So this value is 25. Okay. Does that change? No, it does not change. That is solid. So that is not changing at all. So I know I have an x value. I have a y value also. Okay. It's going to be some touching at some value up here. It's going to be going here. And it says, so because of this, I know that I'm going to have, let's see. So where am I at? Sliding towards the floor, so that means it's going down, right? Okay. If the foot of the ladder is sliding away from the base of the wall, so this right here is going this way, right? So that means, what does it say about my x values? Yeah, it's increasing, right? So x values are going to increase when y values decrease. Okay, good. So right here, so if the foot of the ladder is sliding away from the base of the wall at a rate of, okay, 15 feet per second. So now, in my diagram, what does that tell me? In my diagram, what does that tell me? So that's my x's here, right? Okay, right here. Foot of the ladder sliding away, going that way, right? At 15 feet per second. So that means that that's going to be a rate for my x's, isn't it? So what would I call that? dx dt. Very good. So dx dt is equal to 15, right? 15 feet second, right? How fast is the top of the ladder sliding down the wall when the top of the ladder is 7 feet from the ground. So what does that actually tell me? The y value, right? So when my y value, so when y is equal to 7 feet. Yes? Okay, so I love my Pythagorean theorem over here, right? Okay, because it's going to be this. So for all of this, I'm going to use my Pythagorean theorem, which is x squared plus y squared is equal to 25 squared, right? Okay, so I'm going to have that right there. So that's my whole Pythagorean theorem for this, because I'm going to solve for that given this. Now, when we do that, we're going to use this function right here that I created for this right triangle. I guarantee you'll always have some like this stupid ladder problem on every single test every year. So it's not really stupid. I like it. You know, I used to hate it, but then I'm like, it's there every year, so this should be a freebie on ones that you know it will be there. So let's take the derivative of everything. So it's going to be a 2x dx dt plus 2y dy dt equals, what's the derivative of this thing right here? Say 0. 0, because there's no variables, right? There's no variables, so that goes to 0. So that makes life super easy because it goes away. So now I have the rates here. So I now have rates, and I have some values that I can now plug in. So I know that dx dt is going to be 15, and y is 7. So, and we're looking for how fast is the top of the ladder sliding down. So now we're looking for the rate that this is. So we're looking for dy dt. So we're looking for dy dt. So let's go ahead. I'm going to start plugging in stuff. So it's going to be 2x, and that's going to be right here. My dx dt is going to be, what's that? 15 plus 2 times 7, right? And dy dt equals 0. So, since this thing is fixed, this is fixed, isn't it? Okay, so now I'm going to go back to my Pythagorean theorem over here, and I'm going to find my other value. Because I know when y is this. So I basically say I have a right triangle. My y has to be 7. My x has to be 25. No, I'm sorry, my hypotenuse is 25. And so I need to figure out my x here. Because I'm going to have all these values, right? Since this thing doesn't change, and if I know this one, Pythagorean theorem will tell me that one. So let's go ahead and do Pythagorean theorem here. It's going to be x squared plus 49 equals 625. Minus 49, I get x squared is equal to, crap, I don't know what that one is.
576.
5 what? 576. And x equals,
24.
yes, square root of 576, where x is 24. Okay. So now I know that x is going to be equal to 24 because I needed that right here. Because when I get to this point right here, I should only have one variable. And my one variable should be my dy dt. Because that's the one thing I'm looking for. So I use what I know, my handy dandy Pythagorean theorem, okay, to figure out that one. So now it's going to be 24. So it's 24 times 30, so I just multiply these two, plus 14 dy dt is equal to 0.
A little bit.
70, was it 720? Okay, so I get, right here I should get a negative value, right? Just make sure you fill out the paper. So negative 720 is equal to 14 dy dt. Divide both sides by 14. So dy dt is equal to, I don't know, some number. What do I do with my calculator?
360 over 7?
What is it?
Negative 360 over 7?
Negative 360.
That's
So negative 51.429.
Okay, negative, what is it?
51.429.
Okay, so
Whatever.
what are my units? This is important right here because if you put in a fraction,
Yeah.
it's okay. It's okay for the sake of. So if you have a calculator, it helps it a whole lot. So that's going to be that, which tells me that it's going to be what? What are my units here? Feet per second. Feet,
Wait, well, a second.
okay, per second. So there's my rate for that one right there. So what does that say? That's actually going pretty fast, right? So it's a 25-foot ladder, so of course it's actually going to be going down pretty quick. Yep. Okay. All right. So, anyone have questions over this? No? All right. It's coming up to that time, you guys. So,
We're done?
okay. Yeah. Hey, gotta end with the winner, right? Okay. So, what I'm gonna, for the sake of, for the next couple minutes, I'm gonna let you guys that need the tutoring. We'll do the tutoring hours. I mean, right here. Page 234, and then from there, yeah, we're gonna end it here. So don't forget, like, share, and subscribe.
Yeah.
Yes. And don't forget, hit that notification.
Can I just like go?
Of course. Yeah.